In this video, we're going to talk about circles and circumference. So to begin, we're going to go to the definition of a circle, which is the locus or set of all points in a plane equidistant from a given point called the center of the circle. So basically what this is saying is if I start with one particular point right here, I'm going to have that be my center of my circle. Then if I start creating points around it, okay, this locus, and they're all equidistant, they're all the same distance, then what's going to happen is it's going to start creating what we know to be a circle. And it's not just 10 points or 20 points or anything like that. It's an infinite amount of points that make a nice smooth circle that connect. Okay, and when they do that, it gives you a circle. That's not the best looking circle, but you get the idea, hopefully. So that's what the definition of a circle is. So the next definition is a radius, and a radius is a segment with endpoints at the center and on the circle. So basically, you are going to connect the center of your circle, which is here, to any point on the locus of points on the outside. So say for here, and I connect them to make a segment, that is a radius, and it's usually denoted with a lowercase r. Another new term that we have is called a chord. And a chord is just a segment with endpoints only on the outside of the circle. So for instance, I'll make this a point on my circle and this a point on my circle, and I'll connect them, and that makes a chord. So chords can be virtually anywhere inside your circle as long as it just touches the outside of the circle. And last but definitely not least is a diameter, which is a chord that passes through specifically the center of the circle. And you may also know this as well, but a diameter is made up of two collinear radii that are back to back. So since I already have the outside of my circle in orange, I'm going to do the diameter in blue, this light blue. So I'm going to mark the center of my circle, and I'm going to go straight through it and make my endpoints at the ends of the circle. So that is a diameter, which we usually call lowercase d. So what we're going to do next is talk about the notation for these particular words. If you have to name the circle or name a chord or name a diameter, how exactly are you supposed to do that? So in this particular picture, we do have a circle. The center is P. We have 3 points on the outside of the circle, L, M, and N, and we are going to name certain things and make sure that we know the notation for them as well. So what we're going to do first is to name the circle. You have a couple choices here, but the name of the circle is always used, it always uses the center of the circle to do that. So since the center is named P, we call it circle P, or what you can do is you can use the notation of a circle with a capital P next to it, and that also says circle P. And that's a little dot in the middle of that circle in case you can't see, it should have a dot there. Okay, so next we're going to name a radius. And if you look carefully in the picture, I actually see 3 radii. I see the radii LP, this one here. I see PM, and I see PN. And you can name any of them that you'd like to. But since radii are segments, we use the segment notation for it. So for instance, you could say segment LP is a radius, or segment PM is a radius. And the last one would be PN. And I made one mistake naming the first one, which I forgot to mention, is you always list the center of your circle first. So P should be going first. So this should be PL, not LP. So now we're going to name a chord. And since chords do not go through the center of a circle, we do not have to worry about listing the letter P first in this case. And again, chords are just segments. When I look at my picture carefully, the only chord that I see is MN, this one right here. It does not go through the center. It connects 2 endpoints on the outside of the circle. So we're just going to name that MN, or you could do NM, and either way is okay. And lastly, we're going to name the diameter, which of course is also just a segment. And the only diameter I see is the one that goes from L to P to N. So we just do the outside letters. We do not include the center point for a diameter. So we could either name this LN, or we could say that it's NL. Either one of those would be perfectly fine. Okay, so next what we're going to talk about is the relationship between the radius and diameter. So in case you did not know, a radius is half the diameter. That's what this first part says right here. So whatever the length of your diameter is, if you cut it in half, that's the length of your radius. And this right here is just another way to write that. So if I take the measure of D and divide it by 2, which is here, then it would be the same exact thing. So either one of those formulas works. It just depends on your personal preference. This one over here says the diameter would be equal to 2 of the radii put together. So briefly, let's do some examples. So first, if the radius of a circle is 8 centimeters, what is the diameter? So what I'm going to do is I'm going to go ahead and take the formula for diameter and bring it down, which is D equals 2R. And we're going to replace or substitute what we know. So D is equal to 2 times the radius, which I know is 8. And then we go ahead and evaluate that. So D is equal to 2 times 8, which is 16. And then our unit of measure is centimeters. So that's all there is to that. And then the next one is if the diameter of a circle is 25 inches, what is the radius? So in this case, we're searching for the radius. So you want to pull down one of those two formulas in orange above. And I've always used this one instead. So that's the one I'm going to show you. So again, we are going to substitute what we know. And what I know is the diameter, which is 25 inches. So I'm going to replace D with 25. And then I'm just going to compute half of 25, which is 12.5. And our unit of measure is inches. So that's all we need to do there. So next we're going to talk about some circle pairs. If you're ever trying to compare two circles or multiple circles, these are some good things to know. So the first thing is that two circles are congruent if and only if, that's what that if notation means, they have congruent radii. So any two circles that have the same radii are automatically congruent to each other. The next thing is that all circles are similar. In other words, that they're all proportional. There's one more thing too, which is a new vocab word. That's called concentric circles, which are coplanar circles that have the same center. So if I go ahead and I make a center right here, I'm going to call it A, and I start drawing circles around it. For instance, there's a circle with center A, and I keep going. So here's another circle that also has the center of A. So these two circles, the light yellow and the purple, they're called concentric circles because they share the same center and they're on the same plane. So you could do this as many times as you want to. Here's another circle that also has the center A and is also coplanar to the others. So those are concentric circles. So next let's take a look at an example. We're going to have the diameter of circle S being 30 units. The diameter of circle R is 20 units. And the length of DS is 9 units. And our responsibility is to find the measure of CD. So if we take a look at our picture a little bit closer, the length that we're trying to find is just this tiny little piece right there. So we have to make a plan to do this, and at first it may seem a little difficult, but we need to take a really close look at the information that's being given. So any numbers that I'm given, I'm going to go ahead and write inside my picture. So the radius, or I'm sorry, the diameter of my larger circle is 30 units. So we're just going to write that right in here. And I like to do this notation so that I know that it's talking about the entire diameter and not just a certain part of it. The other part that we know is that the diameter of circle R is 20 units. So again, I'm going to do the same thing here. I'm just going to measure that out and make sure that we say that it's 20. And ds is 9 units, so just this part here. So hopefully what I can do is use all these different pieces or just certain ones to kind of figure this measurement out. In circle S, it really just looks like the part that I need is the distance from S to C. So just that one radius part. I wonder if that might be helpful. So in order to find the radius, I have to have the diameter. So the radius here, this length that I have from C to S, would be 15 because it's half of 30. What I also know is D is in there as well. D is right here. Okay, and I also know that the length from D to S is 9 units. And I think that may be enough to figure out the measure of C to D. It looks like CD is going to be the difference between the entire length from C to S, which is 15, and the length of DS, which is 9. So we're going to just do some simple subtraction. We're going to do 15 minus 9, which should give us 6. And that is the measure of our length CD. And our last topic that we're going to talk about is circumference. And circumference is just the distance around a circle. And what's important to note is that the ratio of any circle's circumference to its diameter, or if you take its circumference and divide it by the diameter, will always give you the irrational number 3.14159, etc., which we call pi. So this happens on any circle, and that's why pi is such a big, important number, is because it works with every single circle that you can possibly think of. And in other words, this can create an equation. We can say that C over D is equal to pi. Now, the way that we get our formula for circumference is by using this. So if I were to get rid of this denominator, I would multiply both sides by it since it's being divided. And that would give us the formula that we've always known, which is C equals pi times D. There's one other way to write this, which makes the diameter into 2 different radii. So we could also say that it's 2 pi r, because 2 r's, right, make up 1 diameter. So either one of these is possible for you to use. However, one of them will typically be more convenient than the other. So, for example, if I ask what is the circumference of a circle with a diameter of 6 centimeters, we're going to go ahead and calculate that, and then we're going to also leave our answer in terms of pi. And I'm going to show you what this instruction right here means when we get there. So first of all, I'm going to bring over my circumference equation, and I'm going to use the one that has diameter in it, since that's what I'm being given. If I were given a radius instead, I would use the 2 pi r formula instead. So here we go. We're going to go ahead and do C equals, I'm going to leave pi here, and I'm going to replace or substitute D with 6. Now, anytime it asks you to leave your answer in terms of pi, it means that you leave pi alone. Pi will be in your answer. So we just have to kind of clean this up then. We're going to do C equals, and we never write pi 6. We typically write the number first and then pi afterwards. So we would say that our answer is 6 pi centimeters. That's how we leave our answer in terms of pi. We do not calculate it out using a calculator. So that's going to wrap up this tutorial video, and I will see you later. Unless I don't teach you.